Okay, so 3.4 part 2, so we're just going to continue on. I just have a couple more examples. Yeah, the numbers might get a little bit bigger, a little scarier, but as long as you kind of follow the steps, the process, we're going to be all right. So the first thing we got to do is come up with that list of possible values. And so once again, the numerator is going to be all the factors of negative 30. And so once again, I just kind of like to think about what values divide evenly into 30. So positive and negative 1, 2, 3, not 4, let's see, 5, 6, let's see, let's see, did we jump all the way to 10, I think? Yep, 10, 15, and then 30. So there's a lot of them here. I know this is going to get pretty messy here, but um, we should be able to find a solution fairly quickly, and hopefully it's not going to be too bad. And so then the factors of the leading coefficient are going to be positive and negative 1, 2, 4, and 8. So we have a lot of combinations here, a lot. And so for the first one, when you divide by positive and negative 1, you just get a repeat of all those values from the numerator. So I'm just going to go ahead and list those real quick. All right, so we got quite a few right here already. And then this is going to be kind of interesting. We haven't seen this yet, but now we're going to divide them all by 2, and that will actually result in some repeats that I already have listed in blue right here. So I'm going to do 1 divided by 2 and negative 2, so I get positive and negative 1/2. And then 2 divided by 2 is 1, so that one's already listed right there, so I actually don't need to list it again. Then 3 over 2, so it'll give me positive and negative 3 over 2. And then 5 over 2, positive and negative 5 over 2. And then let's see, 6 divided by 2 is 3. It's already in my list, so that's kind of nice. Um, let's see, 10 divided by 2 is 5. That's already in my list right there. 15 divided by 2 is not, so positive and negative 15 over 2. And then 30 divided by 2 is 15. That's already in my list. Now we got to do the same thing, but we're going to do it with 4. So 1 divided by 4, so positive and negative 1/4. Then 2 divided by 4 is 1/2. So that's actually already listed there. I already have 2 divided by 4, which would reduce to 1/2. That's already there. Then let's see, 3 over 4, so positive and negative 3 over 4. And then 5 over 4, positive and negative 5 over 4. And then let's see, 6 divided by 4 would reduce down to 3 over 2. So that one's already there. It's already in my list. So 6 divided by 4 is 3 over 2. Then let's see, 10 divided by 4 would be reduced to 5 over 2. Once again, that's already in my list. Okay, good. 15 over 4, nope, don't have that one in my list, so we got to add that one. And then 30 divided by 4, which would reduce to 15 over 2. That's already in my list, so I don't have to worry about writing that one. Okay, I know this is pretty tedious. When we actually start doing the synthetic division, we're only going to work with the whole numbers. You could work with the fractions if you really wanted to, but I wouldn't recommend it. So let's see, we've got one more we need to do here, 8. So 1 divided by 8, so positive and negative 1/8. And then 2 divided by 8, which would reduce to 1/4, so that's already there. 3 divided by 8, that's not listed yet, so we'll put that there. Let's see, 5 divided by 8. And let's see, 6 divided by 8 would reduce down to 3 over 4, which is already in my list. Then 10 divided by 8 would reduce down to 5 over 4, which is already in my list. And then let's see, 15 over 8, that doesn't reduce, so we're going to have to go ahead and put that one there, 15 over 8. And then the last one would be 30 divided by 8, which are both even, so we could reduce that to 15 over 4, which is already in my list. So It's a long list. Okay, most of them aren't going to be like this, but I wanted to show you one that was like this because the homework's sometimes pretty random. And so you might get something pretty messy like this. And to be honest, you could just come up with the whole numbers, the first row I have right here. Okay. Once you have this part of it, really that's what we want to work with anyways, are the whole numbers. So the other ones, I just wanted to show it to you guys, but really I'm just kind of focused on this top row that I have right here. So now it's time to just start trying this out. Now, um, the first two, I got really lucky. The first number I tried worked, and so let's see how this turns out. So let's see, I'm going to start with trying 1. So we're going to drop the 8. 8 times 1 is 8. 8 plus 10 is 18. 18 times 1 is 18. That's going to add together to give us, let's see, what is that going to give us? Negative 19. Negative 19 times 1. And then that adds to negative 49. So I did not get a remainder of 0. That's what typically is going to happen. Okay, that's typically they're not going to work. So that one didn't work. So now we need to try a different number. So let's try -1. Maybe -1 will work for us. So we're going to try -1. So by the way, I'm just going to scratch that out. So let's see. What about -1? So drop the first number. 8 times -1 is -8. Add that together, that's 2. 2 times -1 is -2. Add that together, that's -39. -39 times 1 is positive 39. Add that together, and we get a 9. So, nope, that one did not work either. Okay, so let's move on, and we'll try 2 next. So let's see, 8, 10, -37, -30, and we're going to try 2. Drop the first number. 8 times 2 is 16. Add that together, that's 26. 26 times 2 is, what is that, 52? Okay, add that together, and I think that gives us, what, 15? That looks right, 15. And so then 15 times 2 is 30. -30 plus 30 is 0. Bingo. So I hit a bingo. So I know that one of my solutions is 2. So definitely 2 is part of my solution. Then we take the quotient and put the variables back and reduce them by a power. So that's going to be 8x squared plus 26x plus 15. And now we want to go ahead and figure out what makes the quotient equal 0, right? Now technically what we've done is we've basically factored this right up here. My solution was 2, so as a factor that would be written as x minus 2. And then this down here, the 8x squared plus 26x, and then I have that plus 15. So technically what I've done is I've factored it into these two pieces right here, right? And we're trying to figure out what makes it equal 0. So I know 2 works, but now I'm going to have to focus on the trinomial here and factor this down. And so, yes, these numbers are a little larger than we've been working with. And so if you need to, you can use a calculator, but it shouldn't give us too much trouble. So let's see, 8 times 15. Let's see, that's 120. So I've got to find two numbers that multiply to give me 120, but then also add up to 26 in the middle because I want to split that. And so if you have no idea where to start, grab a calculator and just start dividing this by 2. So 2 times 60, but that does not add up to 26. Divide by 3. 3 times 40, well, that does not add up to 26. Divide by 4. Let's see, 4 times 30, that would add up to 34. No, but I'm getting closer. Let's see, divide by 5. Let's see, 5 would, let's see, 24, I believe. Okay, that adds up to 29. Okay, I'm getting close. All right, divided by 6. 120 divided by 6 would be 20. Oh, bingo. 6 times 20 is 120, and those two numbers add up to 26. So I still have my 8x squared, and then it doesn't matter which one goes first. I'll put the plus 6x, and then the plus 20x. It doesn't really matter. And then plus 15 equals 0. Okay, so now we do our factor by grouping process right here. So on the first set, I can pull out a 2x, and that will leave me with 4x plus 3. Okay, on the second set, I want to have the same leftovers, and so when I look at this, it looks like they're both divisible by 5. So I pull out that 5, and I have a match. Okay, it's very important that you get a match. Okay, so then from here, we're going to factor out the 4x plus 3. We're going to factor that outside here. So we pull out the 4x plus 3, and then my leftovers in this example is going to be 2x plus 5. Okay, so that's what we factored the blue part into. And just to kind of connect all the dots, so my other factor was x minus 2, right? X minus 2, so I'm going to tack that on here just to kind of, like I said, kind of connect all the dots here. So this is equivalent to the original function that we had up there, but it just wasn't in factored form. So that right there, if you were to multiply those three factors together, that's equivalent to 8x cubed plus 10x squared minus 37x minus 30. If you don't believe me, you can go ahead and do it for fun. All right, but what I want to do is finish this off and find all my solutions. So once again, we're trying to figure out what makes this equal 0. So you need to take each one of these, set them equal to 0, and solve. So 4x plus 3, set that equal to 0. 2x plus 5, set that equal to 0. And then x minus 2, set that equal to 0. Because these three things are getting multiplied together. And if any one of them is 0, the whole thing will go to 0, because 0 times any number is going to equal 0, right? So let's see, on this first one, subtract by 3, and then we're going to divide by 4. And so our first solution that we got here is negative 3 over 4. And once again, if you go back and look in your list, that will actually be part of my list up there, right here. Positive and negative 3 over 4. So we ended up getting the negative version of 3 over 4 right there. So that was within that set of possible solutions that we came up with. So that's one of them. Then let's see, we'll subtract by 5 on both sides, and then divide by 2. And so we're going to get x equals negative 5 over 2. That's another one of my solutions. And once again, if you go look at your list, you'll see that one in your list. And then the last one was the first one we got, was when we tried 2 and it worked out. We got a remainder of 0. So those are my three solutions. So once again, it doesn't matter what order you list these, but those are going to be our three values right there that will satisfy that function and make it equal 0. So those are also known as x-intercepts. Okay, so the next two I don't think will be quite as bad as that one as far as the numbers going, getting a little crazy. So see, we have a 6 here and a 1 here. So that should make my set of possible solutions a lot easier to work with. So the first part we do is list all the values that divide evenly into negative 6. So positive and negative 1, 2, 3, and 6. And then the leading coefficient's a 1, so that makes life a little bit easier, because then I'm just going to get a repeat of the numerator of all my possible rational solutions. So these are just my possible rational solutions. Sometimes our solutions are going to be messier, and whenever that happens, we're going to have to do the quadratic formula. So let's see what happens here. This might be one of those examples. All right, so once again, I get this thing set up for my synthetic division, and we'll just kind of go in numerical order. I'll start with 1, and let's see, I drop the first one. 1 times 1 is 1. Add that together, multiply. 1 times, or 5 times 1 is 5. Add that together, that's 2. 2 times 1 is 2. Add that together, it's negative 4. So nope, 1 does not work. All right, maybe negative 1. Let's see, 1, 4, negative 3, negative 6. So let's see, let's try negative 1. All right, so drop the first one. 1 times negative 1 is negative 1. Add that together, that's 3. 3 times negative 1 is negative 3. Add that together, that's negative 6. Negative 6 times negative 1 is positive 6. Add that together, we get 0. Bingo. Bingo. So we found a solution. We know negative 1 works. Now, what we're left behind with when our quotient in this example is going to be x squared plus 3x minus 6, and we got to figure out what makes the quotient equal 0. Now, you can play around with this, try to figure out what's going to multiply to give you negative 6 and add to 3, but you're not going to be able to come up with that combination in the current format that we're in. Um, like I said, you can try and it's not going to work. So what you want to do is the quadratic formula. So that goes back to our first unit. That goes back to unit 1. So the formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so what we're going to do here is, let's see, this will be my A. I'm going to erase the M and N part now, our M and A part. So this is my A, B, and C value. So we want to go ahead and substitute those in there and simplify it, and that will find us our other two solutions for this particular equation. So let's see, we're going to have x equals negative 3 for my B value, plus or minus the square root of 3 squared minus 4 is part of the formula, then a times c, and then all divided by 2 times a, so 2 times 1. All right, so now it's just a matter of kind of cleaning this up and simplifying it. So let's see, we get x equals negative 3 plus or minus the square root of 9, and then 4 times 1 times negative 6, and then I'm subtracting it. So when you do all that, that's actually going to turn into a plus 24 right there. And then all divided by 2 times 1, which is 2. Then let's see, we're going to end up with negative 3 plus or minus the square root of 33 all over 2. All right, so the solution set here is going to be that negative 1, and then this is really two solutions right here. So negative 3 plus the square root of 33 over 2, and then also negative 3 minus the square root of 33 over 2. So those are my three solutions for that. So in this particular example, I wasn't able to factor it, so that's what I had to do. And so if you were to put this in the calculator, let's see, this one right here would be roughly about like 1.37 or whatever, and this one would be negative 4.37. So we don't want the decimal answers, I want the radicals, but just so you can kind of get a feel for what those numbers are. And so you'll notice whenever you have the radicals, obviously it's not going to be in my list because those are not rational numbers. So it wasn't in my original list that I came up with up there. Okay, we're going to do one more. And once again, yeah, we got kind of a big number we're going to deal with right here with the 120. But luckily, my leading coefficient, though, is just a 1. Okay, so really, it's going to get divided by 1 and negative 1. So I'm just going to go ahead and list these because that's what it's going to end up being. Okay, so numbers that divide evenly into 120. There's going to be quite a few. Really, if I just list the first couple, that would probably be fine. But here we go. So positive and negative 1, 2, 3, 4, not 5, 6 would divide evenly into it. And I mean, you could use a calculator if you really wanted to see, divided by 7. I don't think that works. I think 8 does. So 8 should divide evenly into it. 10 divides evenly into it. Let's see, 12 would divide evenly into it. Let's see, what else? I think 15, positive and negative 15. Then the next one would be positive and negative 20. Then let's see, the next one would be positive and negative 30, and so on. But really, um, you're gonna hit on one of these first couple right here, hopefully early on. So let's go ahead and do that. Now, what I will point out, what's different about this one compared to the other ones is we have a power of 4. And so that probably, or it does mean we're going to come up with 4 solutions. Now you can get repeat solutions. I think they should all be unique, though here they should all 4 be different. But let's go ahead and get started and find out. So let's see, I'm going to have a 1, an 8, a 5, a negative 74, and a negative 120. All right, so we'll start with 1. I don't think it works, but we'll try. Let's see, 1 times 1 is 1. 1 plus 8 is 9. 9 times 1 is 9. 9 plus 5 is 14. 14 times 1 is 14. Add that together, that's going to be negative 60. Negative 60 times 1 is negative 60. But that adds up to negative 180, which is definitely not 0, so that does not work. So let's try negative 1. So let's see, 1, 8, 5, negative 74, and negative 120. So let's see, let's try negative 1. So drop the first one. 1 times negative 1 is negative 1. This will add to 7. 7 times negative 1 is negative 7. See, that will add to what, 2? Or negative 2? Then multiply that, you get negative 2 here. Let's see, that's going to add to negative 76. Multiply that there, we get positive 76. But that is not going to work. What is that? Negative 44, I believe. And so, nope, doesn't work. A little bit closer to 0, but that's not going to work. So let's see. Hopefully 2 or negative 2 is going to work. So let's find out. So let's see. All right, so here goes for 2. Let's see, so drop the first number. 1 times 2 is 2. 2 plus 8 is 10. 10 times 2 is 20. 20 plus 5 is 25. 25 times 2 is 50. 50 and negative 74 combined together to give us negative 24. And then that multiplies to give us negative, what is that, 48. And so not quite. So I get negative 168. So still not that close to 0. So that doesn't work. Let's try negative 2. I kind of have a good feeling about that one, I hope. So let's see, 1, 8, negative. So really you just kind of just do the same thing over and over and over. So here we go. So for negative 2, so drop the first one. 1 times negative 2 is negative 2. Add that, that's 6. 6 times negative 2 is negative 12. Add that together, what is that, negative 7. Negative 7 times negative 2 is positive 14. That'll add up to negative 60. Negative 60 times negative 2 is positive 120. And that gives us a 0. So bingo, we hit one. We hit one. Okay, so our quotient, what's going to happen here, though, is our quotient is going to be x cubed plus 6x squared minus 7x minus 60. And so you could try to factor it, but it's not going to be factorable. You could try the factor by grouping, but it will not work. So what we need to do is keep trying more numbers. But the good news is we can use these new coefficients. We can use the 1, the 6, the negative 7, and the negative 60. So we don't have to use the same numbers we were working with. Okay? And so that's what we need to do. We need to kind of continue on. So I'm going to kind of come over here. So like I said, now we're going to use 1, 6, negative 7, and negative 60. So we're going to use these 3 numbers. Now, it is possible that negative 2 can work more than once. Okay, remember back when we talked about multiplicity? So I could have a multiplicity higher than 1 on this. So just to be careful, I better try negative 2 again, just to see if it happens again. So let's see. We'll drop the first one. 1 times negative 2 is negative 2. That adds up to 4. 4 times negative 2 is negative 8. That adds up to, what is that, negative 15. and then that multiplies to give me 30, which then would add up to negative 30, and so that doesn't work. So um, it doesn't mean that negative 2 didn't work in the beginning. It did. That was one of the factors. It just doesn't have a multiplicity other than 1, so it only happens once. So we need to move on and try 3 next, and then maybe negative 3. Hopefully we'll hit 1 pretty quickly, because it can be a little time consuming, but just be patient. So let's see, we're going to use those same 4 numbers, okay? And that makes life a little bit easier. And so next on our list was the 3 and negative 3. So let's try 3. So we drop the 1. 1 times 3 is 3. Add that together, that's 9. 9 times 3 is 27. Add that together, and let's see, what does that give us? Positive 20. And then 20 times 3 is 60. Yay, we hit another one. Remainder of 0. So yes, I hit another one. So now I know 2 of them. I know negative 2 works, and I know 3 works. Now maybe 3 works again. I'm not really sure. But at this point, now my quotient is going to be a quadratic. It's going to be x squared plus 9x plus 20. And so what that means is I can either factor it, or I can do the quadratic formula. And it is factorable, so I might as well just factor it. So I got to figure out what multiplies to give me 20 but add up to 9. So let's see, I believe this would factor into x plus 5 times x plus 4 equals 0. So there are my other 2 factors, so I can get my other 2 solutions. So this one would be at negative 5, and this other one would be at negative 4, at negative 5 and negative 4. Okay, so what does that mean? Well, I found all of them. I found all 4 of my solutions. So I know negative 2 worked, 3 worked, and then I was able to take the quotient once we got it down to a quadratic equation. And fortunately, I could just factor it. I didn't have to do the quadratic formula. So there are my 4 solutions. So I have negative 2, positive 3, and then down here I found 2 more, negative 5 and negative 4. And if you notice, those were all numbers that were on my original list of values to try. So they were all within this list. Okay, and like I said, I underlined how far I thought it would go, and guess what? They were all within that list. Oh, you know what? I didn't do 5. Hmm. Okay, 5 should have been on my list. Yes, 5 definitely divides into that evenly. So positive and negative 5. So my bad. So I actually missed one right there. So, yep, be careful. Like I said, once you start getting into double digits, I really wouldn't worry about those. You're going to be able to hit one in the single digits, and then also when you're dealing with the fractions, I know it can get a little crazy. We had on the previous number 3 down here. Once again, I would just deal with the whole numbers when you're trying to hit your first one. And once again, it's going to be in the single digits. You're going to hit something like a 1, a 2, a negative 2, something like that. You're going to hit one of those. So the main thing is just kind of be patient, kind of treat it like a game, come up with your list of possible solutions, and then you just have to start trying them, and you'll hit one eventually. And then from there, it should get easier. Once you hit one, it's easier to find the next one, and so on. And most of them are only going to have 3 solutions. This last one had 4. But anyways, play around with it, and if you got questions or concerns, or if you want to send me the one you're working on, go ahead and take a screenshot and email it to me, and I'll be more than happy to kind of give you some hints to get started.